Hello friends, welcome back to our channel. So in today's session we'll see one more concept in a compiler design. So in our last session we have seen how to construct the syntax tree, and today we'll see the fourth phase of a compiler. It's an intermediate code generation. So in today's session we'll see the introduction about the fourth phase of a compiler. So the fourth phase of a compiler, which is an intermediate code generation. So already we have seen the different phases of a compiler. So which starts with a lexical analyzer. So the output of a lexical analyzer will be the lexemes, and that will be given as an input for the second phase, that is a syntax analysis, which will be producing the parse tree, and that parse tree will be given as an input for the third phase, that is a semantic analyzer. It will check all the rules whether the productions are perfect, that fits the program, and also type checking. Okay, also type checking will be done, so that's why we can also call it as a checker, right? And the output is a modified parse tree, or we can also say annotated parse tree. So that will be given as an input for the next phase, that is a intermediate code generator, which will be generating the intermediate code, right? So see, the first one is a lexical analyzer. So the next one is semantic checker, sorry, syntax analysis, and from semantic analysis, and the next one is a intermediate code generator. See, this is the most important phase. This is the most important phase. So why? Because so among uh, six phases, we have studied about the six phases, right? Lexical analyzer, syntax analysis, semantic analysis, intermediate code generator, uh, uh, code optimizer, and target code generator. So in this, the first four phases will be considered as a front end. Okay, front end, and the last two phases will be called as a back end. So we'll be using these words in every concept. I mean, nowadays we are able to listen these words like front end. What is a front end? What is a back end? Like that. So front end means this is a machine independent. Machine independent. So that means this can be used in any kind of machines. For example, let us take a different operating systems like Windows operating systems, Linux, or Mac, like that, different Android. So say different operating systems will be there. So if you want to design a compiler, okay, if you want to design a compiler, so you need to use all these phases. We know, so because our subject is a compiler design, so if you want to design a compiler, you need to work out on all these phases, then only a compiler can be designed. So coming to this front end, the same, I mean, whatever the design we are doing so far, that can be used for both, all the three. The same front end can be used for different systems, but from here, whatever the code we are generating from this intermediate code generator, that will be given to the next phase, which is a starting phase of a backend. These two are machine dependent. These are all machine dependent. That means, so whatever the things we have learned so far, that is a common to design the compiler for any kind of operating systems. But from here, this is depends on the machine. The two phases code optimization and the target code generator will be depending upon the machine. So that will be different for Windows, different for Linux, and different for Mac, right? So if we can make use of this front end for any kind of compiler, but this backend is a crucial. So whatever the output we are getting from this intermediate code generator, that we are call it as a intermediate code. Intermediate code. So the output, so this is the output. This is the output. Okay. The output of intermediate code generator is a intermediate code. So intermediate code, that implies it will be the bridge between the front end and the back end. So that will be the input for the first phase of a back end. So that's why we are calling it as an very crucial. Okay, it's a crucial. So it will, the definition of intermediate code generation is it's a fourth phase of a compiler which will convert the high level program. So the input for this lexical analyzer is high level program, or we can also call it as a source program, source code. The source code, the conversion of source code to intermediate code. So what is the, I mean, what is the output of this compiler means high level to machine code. So in between high level and a machine level, so there is a intermediate code which is the output of this intermediate code generator. Now, how many ways we can represent this intermediate code generator? Different types of intermediate code generator. Okay, so what are the types of intermediate code generator means? See, types of intermediate code generator. So I'll shortcut it as ICG. Okay, so this can be done in different ways. One is postfix notation. Postfix notation. So I think you might be studying this postfix notation in your data structures, right? And another one is three address code. Three address code, we can also call it a tag. The next one is a syntax tree, and the next one is directed acyclic graph, which can be called as DAG. So these are the three different types of intermediate code generators. Okay, so this is a postfix notation, three address code, syntax tree, and directed acyclic graph. So in among all these four, we have already studied about this postfix notation and also the syntax tree. Now we need to focus on three address code and directed acyclic graph. So what is the next phase of this one? So the next phase of this intermediate code generator is a code optimization. Code optimization. So that means with respect to the memory, okay, and also time, space complexity and time complexity, the code can be reduced, right? So the code can be optimized. So among all these four, the best type of intermediate code generator to generate the code optimization, to make the code optimized, is this three address code. Hope you understood. There are different types of intermediate code generators. So these code generators will be generating the intermediate code, which is in between the high level and a machine code. But among these four, this three address code is perfectly suitable to generate the optimized code. So we'll be concentrating more on this one in our further classes, and also we will see what is a directed acyclic graph. Okay, so we know already the syntax tree. So reducing the memory of this syntax tree is called as a directed acyclic graph. So we know the postfix notation. So I'll give an example, simple example. So let it be a plus b into a minus b, or a plus b. See, if the expression is in this way, we know the postfix expression. What is the postfix expression? If the expression is in this way, this is an infix. Infix means the operator will be in between the operands. So postfix means the operator should be after the operands. So if a plus b, the postfix of this particular thing will be ab plus. So you can consider this one. So ab plus and into AB plus. So just go with the priorities, operator precedence. So in this case, operator precedence, brackets will be having the highest precedence. So first we will be converting these brackets. And now you can see already we have done, and among these, the star is the having the highest precedence. So we can say AB plus star. So this will be the postfix notation for the given expression. So similarly the syntax tree, so already we have seen in the syntax tree the operands will be the leaf nodes and operators will be the intermediate nodes. So we can say star and plus A, B plus A and B. So this is a syntax tree for this particular expression, right? So this already we have studied, and I'll post the complete compiler design playlist link in the description, so that just go through that. Okay, how to construct the syntax tree and everything. And in our further sessions we'll focus more on first directed acyclic graph, and then we'll see what is a 3 address code and how we can convert this any expression in this 3 address code. Okay, because so this 3 address code is the most suitable for giving the input for the next phase, which is a code optimization, right? So these are the different types of intermediate code generators. Hope you understood this one, and I'll stop here. And if you are having any queries regarding this one, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed the session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.